All right, so we're going to follow up on our 5 rules we just learned, things, shifting and transformations of our parent functions. So first of all, to review, we have those 10 basic shapes. There was 8 that were functions. We have these, and these were the 2 non-function that we kind of just used to give us an example of a non-function and that they were symmetric with the x-axis. But for our shifting rules, we only use the function ones, the function shifting rules. So we take these 8 parent functions and we apply these rules to them. So the first one was a vertical translation, which is your up and down arrows here. If you have a plus or minus added to the end of your function, or it can be in the front of the function, but the thing is it's not in the parenthesis with it. It's not in the action. It's not in the absolute value signs or under the radical or in the denominator. It's aside from that, outside of the action, an independent, I will call it, add or subtract, shifts things up and down. The horizontal translation is the trickster, where you got to watch. If it's inside of the parentheses or anyway included in the action, which could mean in the square root sign like that, that's a horizontal translation. Again, that means left, right. It would move it opposite, back 2 places. That would be the arc, back 2 places. If it's in the denominator like so, that even means it's included inside the fraction. If it were vertical, it'd be out here, -3, very independently added or subtracted. But this is included inside the fraction action there. So it is still this horizontal. That's the one to watch for. It's inside. You could consider that in a parenthesis. If we were doing it on our calculator, if you type that in your graphing calculator, which we're getting ready to do, you would need to say 1 divided by parenthesis x minus 3 to even plug that into your graphing calculator correctly. So it is considered inside of a parenthesis. So anyway, it's opposite. The horizontal translation is always opposite, so you'll be moving it +3 places and then drawing your sketch like so. The other thing, or the reflections, we got 2 types of reflections. The reflection across the x-axis, if there's a negative in front of the entire function, and it seems like most all the examples we do much more of this. If we put a negative in front of any of these, it flips it across the x-axis, which would be this way, you know, upside down. We'd flip it upside down. If the negative is only on the x, like if I put a negative right there inside of the root sign, not in front of the whole function, just on the x only, that flips it across the y-axis, left, right. Then the last thing is the stretching and shrinking of the graph. That's affected by the multiplier, the number in front of the multiplier in front of the function. So if I put a 3 in front of that, it's going to make the graph stretched or shrink. And so we talked about that in the last video. If the number is greater than 1, it's going to make it more narrow or skinny, you might say. It's stretched vertically. And it shrinks it or makes it look wider because it goes up slower with a fraction multiplier if it's between 0 and 1. If that a multiplier is between 0 and 1, the graph is going to be wider. So an example of that might be y equals 2/3 x squared. So that's going to be a parabola, and it's going to be wider than its basic. How much wider is it? You'd have to plot a point to really kind of emphasize that exactness. But in general, you should expect it to look wider. So what we're going to do now is we're going to practice with your smartphone calculator, or you can use your regular graphing calculator, or you can just sketch these. I always say this is an optional way to do it, but I am going to practice through these examples in this way. So get your app ready if you're using your calculator app, and you remember I've downloaded the Calculate 84. It looks like that, and I need to clear those out. Okay, I've already plugged in this first one. Oh, there's a big glare on my screen, isn't there? Let's see if I can get rid of that. Those are those fluorescent lights over me. That makes it a little too dark, but hopefully the screen shows up there for you to look at better. All right, so I've typed in y equals the 2x plus 3 squared minus 4. That's how you type that in, and we're going to look at the graph. So I would like you to look at that, and I've reminded you on this first sheet what all the functionalities are of your graphing calculator, if you want to look at that. And then we're going to practice this one. Let's practice. So I'd like you to explore that screen for a little bit and kind of see what you think. There's something going on with the 2, the 3, and the -4. Those are the players. The parent function is x squared, right? So that's my first question to you is what do you think the 2, 3, and 4 do in the equation? By maybe looking at this, maybe using the touch screen and seeing if there's anything you can detect that way that makes you think. Say you forgot all those rules from the other page and you just wanted to look at the screen, what would you think? Then I want you to figure out the vertex, estimate the vertex, and you can try to get, that means that lowest minimum spot. Sometimes it's hard to get the cursor to go exactly where you want it, but I sort of have it there. And it looks like -2.9, -3.9, but you know, sometimes it doesn't give you the exact number that way with the trace. It's kind of an estimate. So to know for sure, we're going to use second of trace, which is calculate. It's got a lot of the important answers, you might say there, and pick minimum, because that's going to be where it dips the lowest, minimum, and hit enter. Then it does this thing where it wants you to put the cursor on the left side of it, the left side of where you think the lowest spot is, hit enter, and then move the cursor over here on the right side of it, hit enter, and then it tells you the answer. So the minimum, I don't know if you can see that screen, I need to make this bigger. There, maybe that's helping. So -3, -4. That's where the vertex of this parabola should lie. And that stands to reason what's going on with this 3 and 4 that I mentioned earlier. The parabola has been moved opposite of this. It says +3, so it moved it back 3 places. Do you see how it's shifted back 3 places? And then the 4 is shifted down 4 places. So that's actually how we find our vertex of our parabola. It's the opposite of this and then that, the minimum value. Next, what is the parent equation? Just asking you that, just to remind you, there is a parent equation going on here. It's the parabola shape, so you should write in what? The y equals x squared. And then I want you to list the effects of each value around the parent. Could you do that? Could you tell me what the 2 does, the 3, and then -4 based on our earlier lesson? And so we should be able to tell, you know, the vertex is affected. This is the horizontal shift. So you would say horizontal, -3. Vertical, what is that? The vertical shift was -4, and that made up our vertex. And then what's going on with that 2? That is our stretch factor. Stretch of 2. So this graph should be a little skinnier. Let's see, what does a regular parabola look like? So let's type in the second equation bar here, x squared. And can you see in its natural parent shape, it's a little bit wider, isn't it? Can you see that? It's not a whole lot different, but this would be the parent function, x squared, and ours has been transformed a bit, and it's a little skinnier. So it had a stretch, a vertical stretch of 2. I should say, a vertical stretch. All right, so let's try it again. Number 2. All right, so let's go back in here and clear these out and type in y equals negative, not in parentheses, x squared, and then +3. There's a negative going on, so we know whenever there's a negative involved, oh, I must have done it too fast. Oh, my calculator's mad at me. Let me turn it off and back on. That does some reflecting. There's going to be a reflection here. So let's see if we can figure out. Well, daggone it. Let's see if I can just clear it and start over. So we have a negative. Oh, I may need to use my actual negative sign, guys. I don't know. That could have happened here. I think I used my subtract sign. Maybe it was mad at me. It wanted the negative sign that's down here. Negative x squared +3. That might happen to you. Maybe it's good I made that mistake. Okay, so there we go. Now it works. So the same question I asked you before oh, I need to change on this handout I've got here. I've still got the things copied above. But there's different things going on this time. We have a negative sign and a +3. So I want you to think about those values, and do you know the parent equation, and you know the effects. So our effect is, because we have a negative on the front of the function, right? The negative sign here flips it upside down. It's a standalone negative in front of the entire function. It's not inside of a parenthesis or under a radical or some way included just on the x. Now if it would have been in a parenthesis, that would have been different. But this is an independent negative sign, independent outside of the action there. So that flips the graph upside down. And then the +3 shifts it up 3 places. And again, let's look at that graph, and we can see that that's so. It looks upside down and shifted 3 places. It is not any skinnier or any wider. There was no multiplier in front of this, right? So it's stayed basic, you know, as far as its wideness. Now let's see if we can figure out where that maximum. This time it's a maximum, right? So let me give you a minute to find your maximum, which we also call the vertex. And we can ask our calculator by going to the second of trace, which is calculate, and ask it for maximum this time. Do you see how it's at the top? So we go over, take our cursor to the left side of that, hit enter, then move your cursor to the right side, hit enter, and it should tell you that it's at 0, 3. Can you see that on my screen? I'm not sure you can, but hopefully you can see your screen. It's at 0 and 3. And that makes sense because it didn't have a horizontal shift. There was no value on just the x, and just a vertical shift of 3. Okay, moving on. Okay, we've got y equals, so let's all do these together. Type in the next one. I've learned my lesson. I need to use the little negative sign down here, not my subtract sign. Sometimes it doesn't matter, but evidently it does here. So 1 divided by 2, then parenthesis x plus 3 parenthesis squared, graph. Okay, again, asking you to find all the pertinent information. Hopefully you're starting to see these patterns and feel comfortable with them. The graph has been moved back 3 places, but there's no vertical shift. So it's back 3 places, 0. That's its vertex. We can verify that. I won't take time to do that, but hopefully you're seeing, yeah, let's do it one more time. Second of trace, let's find that maximum. Since it's upside down, it's a maximum. And it asks you to move your cursor to the left side, hit enter, to the right side of where you think, you know, I think it's right there. So I go to each side of that, and then it tells you -3, 0. -3, 0. That's called the vertex of a parabola, or its maximum spot. Then you'll notice the graph is wider. So it's been shrunk vertically. It has a vertical shrink, I guess I should say. A vertical shrink of 1/2. And it has a reflection about what axis? It's upside down, so that's the x-axis. Reflection of the x-axis, and then we would call that a horizontal shift of 3. Horizontal of -3 to be more specific, or you could say it's moved left 3 places. All right, let's keep going. All right, how am I going to get this absolute value sign? I remember there's a way to do that. So let's see. 5. I think it's under math. I should have checked this already. I may have to come back in to you. Is it under number? Absolute value. So it was under your number here. Absolute value. Oh, there it goes. So there. And then outside of that, I need my -4. So type that in. Let's look at that graph. There's our V graph. That's the parent function. It should be 5 times skinnier. It has or what we call a vertical stretch factor of 5, so it should be much skinnier than the regular graph. And then the -4 is a vertical shift of -4, moved down 4 places. Okay, I'm going to do a couple more here. Let's see how many more do I have. I have a couple more. Okay, do the next one is our rational function, 7 divided by, we will need parentheses, x minus 2 graph. There's a rational function. The graph was able to split that. And I wasn't sure the app would do this because sometimes graphing calculators connect those dots. It can't pick up its pencil, but this app was able to do that, so I'm kind of impressed. I don't know if you're using the physical copy, if it connected those, but that's kind of cool. So it did split. Notice the graph has been moved over to the right. The asymptote, normally it's at, just the regular axes, but it's shifted over. How far? By 2. Notice that that's what the 2 is doing. That's a horizontal shift, positive 2. And the 7 is affecting its curvature. The curve isn't quite the same as it is in its basic form. It has a stretch factor of 7. Okay, one more time. Can we do this square root function? Can I find the square root button? Let's see. And it's a negative, so I need to use this negative sign down here, and then I need to find square root. Let's look under math. Sometimes things are under math, and I do see a cube root and an nth root. Let's see if there's a square root. Okay, I guess I'm going to use this nth root, but if I do that, let's see. I think I have to tell it, it lets me put in whatever I want there, that it's a 2 there, it's a square root, and I'm going to put in, let's see, can I do this? X minus 4. X, that didn't work. I need to get it inside the box. Sorry, guys. Let me clear there. Clear. Oh, now I messed it up. Okay, one more time. Math, and the nth root worked for me. Enter. And I do have to put in my fingers just aren't working correctly here. 2, this is painful for you to watch, sorry. X and minus 4. 4. And I need to tell it it's a square root. 2. I think I got that in there. Hopefully it's easier for you. And then there's the graph. Alright, so look guys, look, it's upside down. That's what the negative sign in front of the function does. It flips the graph or reflects it across the x-axis. And then it moved it over positive 4 places. And the parent function is that square root function. All right, we could do those all day, right? But that's the idea. Hopefully that's enough to give you a pattern, and I hope that helps.